Welcome to Virginia Tech, the home of the Blind Driver Challenge and the future of automotive blind access technology. Can you imagine a blind person behind the wheel of a car? Well, it may not be long before you won't need to imagine. On May 7th, 2009, the Virginia Tech Blind Driver Challenge and the Robotics and Mechanisms Laboratory at Virginia Tech hosted the nation's leading researchers in blind access technology from the National Federation of the Blind Jernigan Institute. On this day, two representatives from the NFB, both blind since birth, officially became the world's first blind drivers to safely, successfully, and independently navigate through a driving course to which they had no prior exposure or training. Not only were they unaware of the course configuration they would face, but neither of them had received any official training in the operation of an automobile or the VT blind driver system. This immediate success speaks volumes to the ability of the non-visual driver interfaces developed by this team to effectively and efficiently communicate the vital information needed to operate and navigate a vehicle. As previously mentioned, we are members of Dr. Dennis Hong's world-renowned Robotics and Mechanisms Laboratory, or ROMELA, who is leading the way in the research and development of countless advanced robotic systems. The Blind Driver Challenge was initially proposed in 2005 by the National Federation of the Blind. To this day, Virginia Tech's ROMELA, with the support of National Instruments, is the only organization in the country to have accepted the challenge. Our goals adhere closely to the mission statement of the National Federation of the Blind Jernigan Institute, which, quote, leads the quest to understand the real problems of blindness and to develop innovative education, technologies, products, and services that help the world's blind to achieve independence. Through the development and integration of novel non-visual driver interfaces on a modified vehicle platform, the Blind Driver Challenge team, consisting of just 9 undergraduate engineering students, hopes to provide the blind with a degree of independence that they have never before experienced. In order to make these goals a reality, National Instruments hardware and software is used exclusively for the operation of the blind driver system. The National Instruments Compact Rio was chosen for its exceptional performance, reliability, ease of use, and modularity. The high-speed data acquisition and processing capabilities of the FPGA and real-time interfaces ensure the highest level of robustness in the design of this extremely time-critical system, which therefore allows the blind driver to gain immediate access to information regarding their quickly changing driving environment. The current embodiment of the blind driver system consists of various sensors and non-visual driver interfaces. A single-plane laser rangefinder is used for environmental perception, and future iterations of the vehicle will be expanded to include vision processing, IMU, and GPS devices, which are all fully supported by LabVIEW, the powerful and versatile graphical programming interface developed by National Instruments and used on a blind driver system. A tactile vest attached to the inside of the driver's seatbelt is used to provide information to the driver to help regulate speed and obstacle proximity. Eccentrically loaded motors are actuated in a manner to inform the driver if they are exceeding the speed limit or approaching an obstacle likely to result in a collision. An audio feedback system is used to instruct the driver where to turn in order to safely navigate the driving course. This feedback is provided to the driver in terms of a number of audible clicks, which the driver hears from a mechanism attached to the steering column to create a click sound for a certain number of degrees through which the wheel is turned. While these systems have proven to be effective in relaying sufficient information for a blind driver to navigate a course, the next step is to improve the interface systems to enhance the driving experience and increase driver independence. Rather than instructing the driver which direction to turn, the driver will simply have non-visual access to the same information which sighted drivers perceive with their eyes. The first system designed to provide these informational cues is called AirPix. This device creates small streams of compressed air on a high-resolution grid, similar to that of an air hockey table. The information gathered by the laser rangefinder regarding the lane location and surrounding obstacles is then processed and output to the driver through the AirPix board. Using their refined sense of tactation on their hand, they are able to quickly perceive the drivable area and react accordingly. All of these devices mentioned previously combine to form the full suite of interfaces which comprise the blind driver system. The use of NI's Compact Rio has enabled the development of this modular and vehicle-independent solution to blind driving. Although a modified dune buggy is currently used as the first iteration of this research platform, the system can easily be added as an aftermarket expansion to any vehicle. The non-visual human interface devices designed for this system may also have positive impacts on potential applications outside of blind driving. For example, the system could be used as a collision mitigation system for sighted drivers who may be tired or otherwise distracted. It could also serve to assist elderly drivers or even train new drivers. Looking beyond ground transportation, these non-visual interfaces would greatly enhance the safety and capability of aircraft pilots in the cockpit environment, which is currently saturated with visual information. In fact, any task which requires fast and precise actions in response to a large amount of data in a short amount of time can be greatly improved by the devices developed through the Blind Driver Challenge. On behalf of Virginia Tech, the Department of Mechanical Engineering, Dr. Dennis Hong's Robotics and Mechanisms Laboratory, and the Blind Driver Challenge design team, I would like to thank all of those who have provided their loyal support along the way. Generous donations and high-quality customer support was graciously provided by National Instruments, Hokuyo Automation, Vicor, TubeMaster Incorporated, and many others. Through these contributions, the Virginia Tech Blind Driver Challenge has created and tested the world's first vehicle capable of being safely operated by a blind driver. We only hope that our efforts will serve as a foundation for the future of research and development in automotive blind access technology, until blind people are able to truly experience the excitement, independence, and freedom of life on the road.